All right, welcome to the next example here. So what we're doing now, in video number one, we were looking at a function itself and determining whether or not our variables x and y showed direct variation, inverse variation, or neither. Now, in this case, we don't have the function, but we have a data table. So we've got x and y values, and we're going to see whether or not this relationship is direct, inverse, or neither. Now, just as a reminder, we've got our direct variation is when our variables are related in this manner. So y equals a times x. That's direct variation. And inverse variation is when we have y equals a over x. Okay, so those are our two different types right here. That's direct variation and inverse variation. So what we want to do, we're going to go ahead and we want to look at the relationships between our x and y values, and we're going to see how they fit into this mold right here. Okay, now if we go ahead and we're going to make a new table of these points. We're going to look at both our x times y and y over x. Okay, now we're going to find the products and the ratios. Now again, what this is going to show us is, remember, for direct variation, we are y equals a times x, and for indirect, we are y equals a over x. Now, what that means is for direct variation right here, all of our values, if we divide both sides by x, all of our values, the ratio should be a constant. So if something is direct variation, then all of the y over x values should be the same. For inverse, right here, for an inverse variation, if we take both sides and multiply them by x, then we should have all of our x and y values equal to a constant. So this is what we're looking for right here. In order to tell if something is direct variation, then the ratio of y over x should be the same, always the same. And if something is inversely related, then its product of x and y should be the same. So let's take each of these points. So 2, negative 12. We take 2 times negative 12, the product is negative 24, and y over 12, negative 12 over 2 is negative 6. So negative 12 over 2. The second one, 4, negative 6, the product, negative 24, y over x, negative 6 over 4, we get negative 3 over 2. The third one, 6, negative 4. We get the product is negative 24, and negative 4 over 6, we get negative 2/3. Last one, we get 8 and negative 3, we get the product is negative 24, and the ratio is negative 3/8. Now again, what you're looking for here is you want to see this constant value. So you're looking to see whether the products are constant or the ratios are constant. Now, you have to remember, this is our constant right here. So since our product is constant, that means that we fit this inverse model. So this right here would be an inverse relationship. Inverse relationship. Okay? Because again, you're not looking at the original function, y equals ax. You're looking at your constant. You're looking at what the ratios or products of your points equal. Okay? So this first example would be an inverse variation because the products are constant. Now let's look. So if we look here, that's exactly what we just showed right there. We've got inverse variation. Let's look at this second one. I'm going to go through this together instead of writing it out. So again, we're going to look at now these new points, and we're trying to see if the products or ratios are the same. So the products, we get 2 and then 8, 24, 64. So 1 times 2, 2 times 4, 3 times 8, 4 times 16. So these products aren't constant, so we know this isn't an inverse variation. If this was going to be a direct variation, then the ratios of y over x should be constant. So 2 over 1 gives us 2, 4 over 2 gives us 2. Looks good so far. 8 over 3, not 2. 16 over 4, not 2. Couple things this points out. First of all, it's not constant, so this would be neither. These are neither direct nor inverse. But notice right here, when we started going through, we did get our first two ratios equal to each other. However, not all four of them were equal. So it just shows, as you're doing your work, don't always assume that one of the table has to be either inverse or direct. It can be neither. And just because you get two numbers in a row, you would never want to stop here and just assume that these ratios are going to be constant and you have a direct variation. You always want to make sure that you go through. So to summarize these types of problems, again, what you're looking for are the ratio and products. When you're given a table of points, in order to find out if they show direct variation, you have to go ahead and take the product of the points to see if they're constant and the ratio. And if the product is constant, it means you have direct variation, or inverse. If the product is constant, it means you have inverse variation. If the ratio is constant, it means you have direct variation because they fit this format. Okay, so remember, if the product is constant, you have inverse. You should all be writing this in your notes. And if the ratio is constant, you have direct variation. And if neither of those are constant, like in this case, if neither of those are constant, then it's neither direct nor inverse variation. Okay, so again, you can always come back and pause this to look at it when you're doing your sample problem. The problem I want you to work on right now is down here. I want you to look at both these two examples and go through the same thing. I want you to take both the product and the ratio and determine whether these show direct, inverse, or neither. And I want you to go ahead and answer both of these in the same question box that's going to come up in just a minute. Again, you're stating whether they're direct, inverse, or neither. So 4 would be your first one and 5 would be your second. So go ahead and label both of those.